All right, we're going to be working on another problem that involves composition of functions, and this will be an important foundation for problems in which we will determine whether or not functions are inverses of one another. I won't spoil the surprise, but I will tell you at the end of the problem what would make me determine that f and g were inverses of one another. All right, I'll tell you now. I know you're dying to know. If you compose f, let me use some color coding here. If you compose f of g of x and it simplifies down to x,
growing up, pretty much everything in my house.
If that composition simplifies to x, and also when you go the other direction and you do g of f of x, like so, and it results also in simply x, when both of those are true, they have to both be true, then f and g are inverses of one another. And what that means is that they undo each other. So that's a very useful relationship to have in some cases. And so in this section, we're going to really just focus on how to find the composite functions in each direction, and also how to identify their domains. So let's start with f of g of x. I will keep using blue when I'm representing f of x and purple when I'm representing g of x. All right, so we'll start f of g of x is equal to this. And there's no need to simplify that any further. Right, so we've got the answer to the first part here. And I've urged you to always be in the habit of considering, when you have a rational expression with an x value in the bottom, consider which x values would make the denominator 0 and then therefore make the entire function undefined. So right away I notice that x cannot be 11, because if it is, I'm going to have an undefined result. That's going to help us doing the next step, which is to find the domain of the composite function f of g. And whenever you do this, you begin with the domain of the inner function, and then consider any values in the domain of the inner function which would result in output values which would then make the outer function undefined. So I already know that the domain most likely is going to be negative infinity to 11. Oops. Advertisement.
Before you and your rheumatologist move to another treatment.
And then jumping over 11 to positive infinity. That's most likely what the domain is, but I just want to verify that this whole range of values, or this whole domain collection set interval, is not containing anything that would not be in the domain of g of x. So I'm just going to write down the domain of the inner function. And this is a linear function, right? It's mx plus b, where the slope is -1 and the y-intercept is 11. So it's a slanted line which has no restrictions horizontally, so no restrictions on x, which means that my domain is negative infinity to infinity, like it is with all slanted lines. While I'm at it, I'm going to state the domain of f as well. Notice that the domain of f has to exclude x value 0. So I'm going to do negative infinity to 0 and 0 to infinity. All right, but I'm just double checking that the domain of G has all of these values in it. And we're just restricting the 11 that would cause the composite function to be undefined. Right, so that's good. That one's done. All right, so let's do the next part, which is the other way around, where the outer function is going to be g of x. So g of x, we're going to input f of x. So the function like this. And then, well, I still can use this color, 15 over x cubed. Right, now this, you'll notice right away, hopefully, that we cannot allow x to be 0 here. So then most likely my domain of the composite function g of f of x is going to be from negative infinity to 0, and then from 0 to infinity. And so just want to make sure that all of those values are in the domain of the inner function. Looking back at the domain of f I have here, it's actually identical, so it's good. Oh, I put that in the wrong spot. That was supposed to go down here. And the answer to this part is 11 minus 15 over x cubed. So that's how you find composite functions. And remember at the beginning I told you that if we were to compose f of g of x and the function simplified to just x, and also if g of f of x simplified to just x, then we would determine that f and g were inverse functions which would undo each other in either direction. That is not the case here, obviously. Neither one of these results simplifies to x. Right, so that's that for now.